Hello everyone. Today we are going to learn about ions. A quick review about atoms. Atoms are the smallest particle of matter that retains all the characteristic properties of matter. Atoms are made of three main subatomic particles: protons, which are positive, neutrons, which are neutral, and electrons, which are negative. So, what is an ion? Ions are charged or non-neutral particles. Basically, they're atoms that are not neutral, or molecules in a couple of cases that are not neutral. There are a couple of different categories of ions. Uh, First of these is the cation, which are positively charged ions. For example, the iron 2 cation or potassium cation are positive ions. Similarly, there are negative ions known as anions. Anions include things like the fluoride ion or the nitrate ion. A quick way to remember which one is positive and which one is negative is that cations are positive. An ion that is made of only one atom is called monoatomic, the prefix mono meaning one. So for example, fluoride, the potassium cation, and the vanadium 5 cation are all monoatomic. They consist of one single atom. Conversely, if an ion is made of two or more atoms that are bound together, it is called a polyatomic ion. For example, the ammonium cation, NH4 with a +1 charge, and the sulfite anion, SO4 with a -2 charge, are polyatomic ions. We will learn more in detail about these in a later unit. So how do we make ions? Ions are not neutral, which means the number of protons and electrons are not going to be balanced for an ion like they were for an atom. Since electrons are the ones who are outside the nucleus, they are far easier to grab, and so electrons will either be added or removed in order to form an ion. Cations are positive, which means they have less of the negatively charged electrons, which means we have to pull off or remove electrons in order to form a cation. The formation of a cation will require ionization energy to be added to the material in order to pull off this electron. This does not happen without that added energy. Anions are negative, and so they will have more of our negative particle, the electron. So anions are formed by adding or accepting electrons. Generally speaking, when anions are formed, energy is released, which is quite convenient as this could provide the energy required to form a cation. This is only true for most, however. So, how do we write ions? Most elements have a common charge, specifically those of the main groups, groups 1 and 2 and 13 through 18. So for example, fluoride's ion, the anion for fluorine, is always F with a -1 charge. This is the common ion for fluorine. Whereas potassium's cation is usually, almost always, potassium +1. Some elements will not have one single common charge. For example, chromium, one of the transition metals, could be either a chromium 2 cation, so a chromium with a +2, or it could be a chromium 3 cation, chromium with a 3+. When you write the symbol for an ion, the charge is superscripted into the top right corner, as shown for the symbols for fluoride and potassium at the beginning of this slide. So, how does this change how we determine the number of subatomic particles in an ion? Good news, protons and neutrons remain the same. We find them the same way. The protons are still the atomic number for the element. Neutrons are still the mass number for the ion minus the number of protons. The only thing that has changed is electrons. Electrons will either be slightly more or slightly less than what they were in the atom, depending on what the charge involved is. A quick and easy way to determine the number of electrons in the ion is to take the electrons that you expect to be there in the atom and subtract the charge. This way, if you subtract a positive charge for a cation, you're kicking off and losing electrons. But if you subtract the negative charge of an anion, you'll actually be adding those additional electrons. So for example, sulfide would have 18 electrons because sulfur traditionally has 2, but sulfide has a -2 charge. 16 minus -2 is actually the same as 16 plus 2, and so the sulfide ion has 18 electrons. Let's do another example, starting from the top. Determine the number of subatomic particles present in the following chromium-2 cation. So we have here the symbol for the chromium-2 cation. Let's first determine number of protons. Protons is equal to atomic number, so there are 24 protons in this chromium atom. The next thing that we should determine is the number of electrons. So we take the atomic number, 24, subtract the charge, which in this case is +2, and we get 22. There will be 22 electrons in the chromium-2 cation. Finally, we need to find the number of neutrons. To find the number of neutrons, we subtract the atomic number from the mass number that is listed. This chromium-2 cation has a mass number of 53. 53 minus 24 is equal to 29, so there will be 29 neutrons in this cation. Let's look at another example, kind of going the opposite direction. There's an ion of an element that has a mass number of 14. There are 8 neutrons present and 10 electrons present. Let's write the symbol for this atom. In order to do this, we are going to have to figure out the atomic number at some point because that will help us identify what element symbol we are going to use. So, if we take the mass number and subtract the number of neutrons, we will get the number of protons. 14 minus 8 is 6, so there are 6 protons present. What does this mean about atomic number? The atomic number of carbon is 6, and because carbon always has 6 protons, so this is a carbon ion of some sort. How do I know what the charge is, though? Well, there are 6 protons minus, we don't know the charge, so let's call it x. But we know that when we subtract x from this, we'll get 10. So if we solve this algebraically, we find that x must equal -4, which means this is the carbide 4 anion. And so the symbol for this is shown here on the right. Superscripted in the top left is the mass number, 14. Superscripted in the bottom left is the atomic number, 6, which is technically optional. And superscripted into the top right is the charge, which is -4.